In this media, you are going to learn about the construction and working of stationary reluctance type torque sensor. This sensor consists of two primary and two secondary windings mounted near the rotating shaft. The secondary coils are coupled with the primary coils by the magnetic flux lines passing through the shaft. The primary coils P sub 1 and P sub 2 and secondary coils S sub 1 and S sub 2 are magnetically arranged in order to produce a circuit similar to the Wheatstone bridge network. R sub P1, R sub P2, R sub S1, R sub S2 are the reluctances of the air gaps between the primary or secondary coils and shaft as shown in the figure. R sub A, R sub B, R sub C, and R sub D are the reluctances produced in the shaft. When the shaft is unloaded, the permeability of the shaft at all its locations is constant and equal. During this condition, the opposite voltages induced in the secondary coils, S sub 1 and S sub 2, are equal, and hence they cancel each other. The torque output of the shaft is therefore 0. When a load is applied on the shaft, the permeability increases in the direction of tension and decreases in the direction of compression. This causes similar increase or decrease changes in the permeability, causing similar increase or decrease variation in the reluctance of the shaft. The variations in the reluctances vary the inductance of the coils S sub 1 and S sub 2. This inductance change produces an unbalanced voltage across the secondary coils S sub 1 and S sub 2. The algebraic sum of these voltages is proportional to the applied torque. Using this parameter, output torque or power of the shaft is shown in the panel meter, as discussed already. The equivalent circuit of the scheme is shown in the diagram. Since the two secondary windings are near the same circumference of the shaft, the change in reluctances at the locations of the two secondaries can be safely assumed to be nil. Rp sub 1 is on the driving end of the shaft, and hence the shaft at that location experiences compression, that is, the reluctance or permeability decreases. Rp sub 2 is on the driven end of the shaft, and hence the shaft at that location experiences tension, that is, the reluctance or permeability increases. Thus, the resultant of primary fluxes has a net value depending upon the load on the shaft. Hence, there develops a resultant secondary voltage between the two secondaries, which is fed to the torque meter. Thus, you have learnt about the construction and working of stationary reluctance type torque sensor.